Okay, so let's wrap up our discussion here about forward rates so we can go on to discount factors. So remember, a forward rate is a very interesting concept. The idea is that a forward rate of interest is one that starts in the future. Okay, in other words, imagine you go to a bank and you negotiate a loan and you say, I want to borrow money for 5 years, but not until next year. Okay. And so what you're actually negotiating then is what we would call a forward rate of interest because it doesn't start today. So the notation that we would use is that a spot rate of interest is one that starts immediately. Okay. So if I go to the bank and say I need money to buy a house, um, which means I want to buy the house now, then whatever rate they charge me is a spot rate of interest. But if I'm in some kind of business situation where I know that in 1 year I'll need to borrow money to start, let's say, the construction on a factory or something like that, the fact that I don't need the money for another year indicates that the rate of interest I'm being charged is a forward rate of interest. Now, of course, that complicates things a lot. With a spot rate of interest, the only information we need is the maturity of the loan or the investment, whatever the case may be. So the notation that we will be adopting is S of T. That would be the T year spot rate. Although I probably shouldn't say year, it doesn't have to be years, but often it is. So S of T means a T-year spot rate. Now, the forward rate is a little trickier because we have to specify two time periods. First of all, when does the interest rate start and when does it mature? So here, this is the forward rate that begins in year T and matures in year capital T. So you can see here, there's a lot of possibilities. And so we have to be careful with the way we express this information. Let's just use a couple of quick examples. For example, F2 comma 3 is the rate that applies. Let me just draw a little diagram of this to make it crystal clear that you've got today's time zero, by the way. Got a rate that applies in this range here. Okay. So in other words, it starts in 2 years and it matures a year later. So in terms of we would describe this as 1 year forward rate, 2 years forward. Okay. So what does that mean? The 1 year forward rate, it's a 1 year rate because it only applies for 1 year from 2 to 3, but it doesn't start for 2 years. Okay, so therefore we refer to it as the 1 year forward rate, 2 years forward. So let's try another one. And again, you'll get used to this very quickly. We're going to need, there's going to be certain topics that we'll be covering where we need to use these concepts very extensively, in particular, when we start looking at interest rate derivatives. We'll be using a lot of forward rates of interest to price them. Okay, so let's just work on this a little bit longer and then we'll get a feel for what these numbers are actually telling us. Or imagine something like this. Okay, 3 comma 7. What would that be? Oops. So my old tablet broke down yesterday, and so I'm using another one that I'm not used to. So here's your 3 and here's your 7. So this is actually a 4-year loan, but it doesn't start for 3 years. So we say that this is the 4-year forward rate, 3 years forward. Okay, so and that's meant to indicate that it's a 4-year loan, but it doesn't start for 3 years, which means that it matures in year 7. Okay, so hopefully that gives us a sense of what this is all about. So in other words, once again, you have to specify what is the starting point of this rate with the capital, a lowercase t. The capital T is the maturity date. The difference between the two is the maturity of the loan, or the interest rate, I should say, because it doesn't have to be a loan. It could be an investment as well. Now, the one oddball case, though, is this one. If let's say I wrote something like this, this is, if you notice, the starting point is today. Now, that's a very odd case, because what this really means, although technically we can think of it as a forward rate, this is actually the 2-year spot rate because it starts right away. So we don't normally use this notation. You don't normally see it starting at year 0. Remember, these spot rates we're using S of t. So they do mean the same thing, but normally we express this as a spot rate S2. But for some formulas, we do use this just to show how it's consistent with these calculations. So anyway, this is what forward rates are all about. Now, we can figure them out from a sequence of spot rates, okay? They're implied by the existing pattern of spot rates. Okay, so in other words, let's say we had a scenario like this. Don't normally, they're not something that exists independently of spot rates. They are implied by the spot rates. Okay, it's not the case that there's two separate markets going on here, spot rates and forward rates. The forward rates are implied by the term structure of interest rates, as we call it. So if, for example, you walked into a bank and said, all right, I see that they're offering a 1-year spot rate of 3% and a 2-year spot rate of 4%. That means that if you look at a timeline, there's the 1-year spot rate, and here's the 2-year spot rate. In both cases, they start right away. This is the forward rate right here. This is the one that equalizes the two investments. Let's say these are investments. I'm putting money in the bank. So in other words, the 1-year rate is 3%, the 2-year rate is 4%. There exists a 1-year forward rate, as you can see, that equalizes the rate of return to both of these investments. And we can figure out what that is very quickly and easily. Okay, let's do that right now. And then once we understand it, we can use just general formulas. So let's say, once again, S1 is 3. It's very obnoxious sometimes there, all right? Okay, so if I were to invest for 2 years, let's say that the principal is $1,000. That's how much I'm putting in the bank. Okay, so what's going to happen is the future value of this investment would be P times 1 plus S1 Sorry, this is 2 years, sorry. S2 squared. Okay. Remember, we spent a lot of time talking about the time value of money. So all you're doing here is multiplying the principal by 1 plus this 2-year rate for 2 years. So you'll have 1,000 times 1.04 squared. Okay. And that works out to be 1081.60. Now, if instead I invest for 1 year and then reinvest for another year, what we're trying to determine here is what rate of interest do I need to earn in the second year to come up with the same future value? Okay, so that means that I'm going to have P 1 plus S1, 1 plus F1 comma 2. And so this is the variable that we're solving for here. So we know that 1,000 times 1.03 times 1 plus, let's call it X, just to keep it simple. All right, so now I'm running out of space. I'll move this to the next slide. So again, we have 1,000, 1.03 plus X equals 1081.60. Or in other words, 1030 plus X. Find out that 1030. And that means that I now subtract 1 from both sides. And that's going to give me 5. It's exactly 5%, or it's close enough. We can round it to 5%. So in other words, F1 comma 2, 0.05. So basically what that means is investing for 1 year at 3% followed by 5% is the same thing as investing at 4% for 2 years. So that's why this is the implied forward rate between years 1 and 2. It is the one that equalizes the investment's returns when we use a 2-year investment versus a 1-year investment, which is rolled forward for another year. So in principle, we can do this for any spot rates that we have. We can calculate the implied forward rate between any 2 time periods. And in fact, we can do this algebraically. So let's see, I think we have a general formula here somewhere. There it is. So in other words, yeah, this is what we just did. So in other words, remember, it was F1 comma 2. And that's what we did. Okay. Now, if you notice, the root is 1. In other words, we just took the simple ratio. If this was a 2-year forward rate, we would have to take the square root. If it was a 3-year forward rate, we'd have to take the cube root. Okay. Because it's 3 years then. All right. So with all that being said, what we could do, if we go back to our examples from Excel, we have this pattern of forward rates. Let's just say that for some reason we need to know the value of F1 comma 3, which ties together these two. Actually, it would be a square root. It's square root because this is a 2-year investment. And that's going to be 6 squared. I'm looking at the, oh, whoops, sorry, I got the wrong one. Sorry. I'm looking for the spot rates. All right, so let's just do that in Excel. And so you'll have square root um, 1 plus this rate cubed over 1 plus this rate without an exponent. And it's approximately, make that a little bigger. It's about 6.6%, 6.57%. Oh, something up here. All right. Now, again, now we can demonstrate this by showing just make some more room here. With a timeline, what you're actually doing is looking for this rate right here. So here you have S1, and here you have F1 comma 3. This should give us the same return as investing at S3 for 3 years. And we can prove it. Okay, so S3 actually, in this case, we don't really need to specify the principal. The future value will be the same. We can pretend that it's a dollar investment. So actually, you know what? I'll tell you what, since I always like to type whenever it's possible. One of the problems with the handwriting, though, is that if you start scrolling around, it can get distorted. So that's going to be 1 plus 3-year spot rate cubed. Okay, so there's for every dollar you started out with, you'll have $1.1924 in 3 years by investing at the 3-year rate for 3 years. For the second case, 1 plus S1 times 1 plus F1 comma 30 squared. Okay, you're going to end up with, I should move this over here. 1 plus S1. And this will prove that we've done, if not, we'll know right away that we've done this incorrectly. Here's the 1 year, the 2-year rate, 1 year forward, as it's called. And yes, they are the same. So we can breathe a sigh of relief. This has been done correctly. So in principle, you can take any of the spot rates and turn them into any implied forward rates that you need. Okay. And in addition to that, whatever forward rates we come up with, if we use those to price a bond, we're going to get the same results as if we use spot rates. We just have to be careful, though. I started to mention this last time. When you price a bond with forward rates, what you're actually doing is you're multiplying a string of consecutive forward rates in the denominator. Okay, rather than, let's say, a spot rate. Like here, for example, I'll just mention this for a 2-year bond. the price with spot rates is going to be less. Whereas with the forward rates, remembering that F01 is the same thing as S1, and you'll end up with the same price. So this S1 plus S2 squared has been replaced by a string of consecutive forward rates. You will not need exponents here. Instead, you have one forward rate for each year in the future at which the cash flow is received. Okay. And then, so this is what I did here. You can see now because here I took the spot rates and raised them to the appropriate exponent. Here, it's a string of forward rates. And we ended up in both cases, not only with the same price, but the same cash flow or present values. These two columns match each other perfectly. That wasn't true with the yields, because remember, these yields are sort of a blend of rates from different years across the yield curve. Here, but again, you still end up with the same result. But here, not only are the sums the same, but so are the individual terms. So why do we do all this? What's the point? Well, because for certain types of investments, they'll be priced in terms of forward rates. And a lot of derivative securities that we'll be pricing are also priced in terms of forward rates. So it's important to understand the relationship between the two. Then we've saved for last discount factors. Now, the discount factors can actually be taken from either the spot rates or the forward rates, but it's usually easier to do it directly from the spot rates. So here's a classic example of this. The discount factor T, now this is going to be a fraction of 1, is going to be 1 over 1 plus the spot rate at time T with exponent T. And what you're going to get is a discount factor, which means a fraction of 1, and that could be thought of as the present value of $1 received at time T. Okay, so using these, let's go back here. I've set up a new column here for this. So here, for example, I'm going to put 1 over 1 plus the spot rate, and the exponent will be the year in which it's received. Now, since I've set it up this way, I can drag this down. I don't have to retype it. And by convention, we often see discount factors quoted with 4 places of accuracy. So that means that the present value of $1 received in a year is 95.24 cents. The present value of $1 received in 2 years is 89.82 cents. And the present value of $1 received in 3 years is 83.86 cents. So I'm going to price this bond with these discount factors. And here it's easy because all I have to do is multiply the cash flow by the appropriate discount factor. And you'll see that they're the same numbers. And of course, the sum is the same. Okay, so there's dividing by a spot rate is equivalent to multiplying by a discount factor. It's just another way of expressing the same information, except that we can think of it in terms of present values. And I think I mentioned the other day when we talked about the strips market is based on discount factors. So what this is telling me, for example, is if I want a 3-year strip, and let's say for a face value of $1,000, that's going to cost me $838.60. In other words, 1,000 times the discount factor. So if you look in the Wall Street Journal at the quotes for strips, they're all done the same way. So for a market like that, the discount factor is the one that we typically use. For bonds, we use yields. And for other types of products, we will use either spot rates or forward rates. In the derivatives markets, we tend to focus on these two. These, like I was saying the other day, typically are reserved for just bonds. Okay. Discount factors sometimes are used as well. These can always be used. They're very flexible. But what you're not seeing here is the rate of return that you're earning. What you are seeing though is that the discounted price you can pay for security. All right. Anyway, now there is a way. You can also convert or solve for forward rates directly from the discount factors. That right here. So here it's understood we're doing this with the discount factors. And so the formula, let me copy it right here. Now, nobody says you have to do this. I think it's much easier to use the spot rates, but it's nice to know that we can do it either way. So this one, for example, now this would have, oh, by the way, in these cases, the starting point is now. So the 0.1 is the spot rate. So what you're going to get here is D1 over D0. Sorry, D2 over D1, sorry. What did I do? No, I got it backwards, sorry. Oh, actually, I put this in the wrong column, wrong row. Right? This was the F1 comma 2. This first one, you don't have to do anything with it. It's just equal to the spot rate. And then for 2 comma 3, you'll have the ratio of these two numbers minus 1. Now, if you notice, I don't have to take any roots because there's only a 1 year difference between these discount factors. So this T minus T is equal to 1. So if you're only looking for a 1 period forward rate, you can just calculate it from consecutive discount factors. Okay. So like I said, though, it's nice, it's good, but it's usually much more straightforward to simply take them directly from the spot market. And then you can see I've been doing working this, I showed this throughout in the spreadsheet that if you take this bond and price it with yields, now remember, if you notice with the yields, all three of them are the same. This is the 3-year yield. With spot rates, where you have a unique spot rate for each of these. In fact, just keep in mind, I'll add this right here. And see, that's kind of the economically, that really doesn't make a whole lot of sense. I mean, in principle, it makes a lot more sense that each cash flow should have its own unique rate of interest associated with it. But this is how it's done in the bond markets. This is the convention. But in economic terms, it makes a lot more sense that here you have S1, for example, S2, S3. And then here, we've got 1 plus. Now, we can think of this as the forward rate, even though we know it's the same as the spot rate. Just keep in mind, these are the same thing. This is 1 plus F01. So it's a sequence of forward rates, consecutive forward rates. Just clean that up a little. And then down here, it would be 0, 1, 1, 2, and then 2, 3. And you'll still end up with $1,000. That's how you know that we've done this correctly. In other words, these numbers have to give us the same price. It's like I compared it the other day with Fahrenheit and Celsius and Kelvin. The how does that work? 0 Celsius, 32 Fahrenheit, and 273 Kelvin. They're all the freezing point of water. They're different numbers, but they mean the same thing. All right. So that's really what we all we need to say about the term structure of interest rates and the alternative ways of calculating interest rates. So what we're going to do now, as I mentioned the other day, we're going to take a bit of a detour. It's about time we introduce VBA because we're going to be doing our assignments with it. And so the one thing I'm a little concerned about is that I think that if you have a Mac, your setup may be slightly different. So we'll see how it goes. Okay, if you have issues with your Mac, um, if you have a Mac, you know, I can look up the instructions for a Mac, but everything about to do is assuming that you have a PC. I don't think the differences are very significant, but there could be a few trivial things that we have to think about. So, and by the way, once that's done in section 4, we're going to actually start our actual first look at derivative securities, which are forwards and futures. Okay, that will come after this. And this is where we start to need those forward rates of interest. Then we'll focus our attention for the rest of the course on options because they're highly complex securities and pricing them is quite challenging. Okay, to say the least. But anyway, right now it's time to visit our discussion about VBA. And so in order to do this, you have to have it installed. It's in your Excel, but it's not automatically installed. I don't know why. So here's what you have to do. Make sure I saved everything correctly. Okay. All right. So now we're going to switch over to the VBA. So there's an Excel spreadsheet here, which is on Blackboard called VBA Code Examples. Now, this happens to be a relatively new computer that I'm using, and I have not actually used VBA since I bought this computer. So my copy of Excel does not have VBA installed. So you can see how this works. What you have to do is go to Options, way down here somewhere. And again, this might be different on the Mac. And what you're actually doing is you're updating what's called the ribbon, which is where all these icons appear that give you all the functionality of Excel. And what you have to do is ask it to customize the ribbon. Now, if you notice, they're already all clicked on, except for God only knows why, they chose to leave this one out, developer. This is the one where you find your VBA editor. So if you click it on and hit OK, it should pop up. There you go. Okay. Now, I don't know what would have been the problem with just leaving it in there in the first place, but that's how Excel does things. Once you get to a developer, here we are. Visual Basic, macros, record macros. This is what we'll be needing. Now, there's a couple of quirky things we have to be aware of. The macro security is set up to not allow you to use VBA. So if I think the way to get around this, it should already say disable with the notification. I think if you put trust access to the VBA object model, and that should take care of the problem. Otherwise, you're going to be constantly getting notices about, oh, we can't do that because, you know, it's not safe or something along those lines. So we'll see how it goes. Okay. Um, we don't want any problems with VBA, but by default, Excel is set up to resist running VBA code because it's worried that it might be a virus or something. So if we tell it, go ahead, don't worry, as long as this is coming from the VBA developer model, it should be safe. All right. Now, what's going to happen? You click on Visual Basic. Now, what you're going to see here is normally it would all be blank, but I've included in here a bunch of examples, which everything from 1 to 17, you'll see them over here. And this is code. This is actual VBA code, and we're going to use these as a template to learn how to use the language so that you can write some relatively straightforward programs to implement what we've been doing. It's it's a fairly straightforward language, but there are some quirky things about it that we have to know. VBA has been around for a very, very long time. It was, if I'm remembering correctly, it was invented in the 70s. And it was, this is in the early days of computer science, very early days, the Stone Age is basically of computer science. So, but the surprising thing is how widely used it still is at this point in time. You'd be surprised how many Wall Street analysts are still using this to develop models because it's pretty straightforward. Although, there's a lot of other better products available. Like, for example, Python seems to be getting very, very popular, but there's a much steeper learning curve for Python than for Excel's VBA. So we're, under the circumstances, I think our best bet is to stick with VBA. But you could, if you're interested, convert this to code into Python, which is a much more powerful language. And surprisingly enough, it's available for free. It's kind of like the poor man's MATLAB. I don't know if you've ever run across MATLAB. MATLAB is a very expensive package. It's a scientific programming language. And it's dreadfully expensive, but it's very, very powerful. Now, interestingly enough, now this is something I hadn't thought to investigate, but if you find yourself needing to do a lot of coding, for math purposes, that is, there does exist another package called Mathematica. Now, the good thing about Mathematica is that they usually have the ability to let you at least use it while you're in school for free. I don't know if that's true for Fairfield. They probably have a license for it. Almost every school, I think, does. And so what happens is while you're still in school, you should be able to download and use Mathematica for free. It's like it's kind of in the same neighborhood as, I guess, Python. Python is a more general all-purpose language. Mathematica is designed to do exactly one thing, and that's math, nothing but math. And one of the good things about it is that it has a lot of fantastic graphics capabilities. It can draw all kinds of wacky functions very quickly and easily. Whereas with Python, I think that would take a lot of extra work. But if you're really interested in learning about scientific programming or mathematical coding with a professional language, you might want to investigate this Mathematica. Like I said, I don't know it for a fact, but it almost certainly is, since you do have a graduate math department at Fairfield, it's probably the case that you can get at least the ability to use this while you're still at Fairfield without having to actually pay for it. Once you graduate, that changes everything. But this way you can at least learn how it works. But I've found that it has a very steep learning curve, very steep. So I think we will stick with VBA because it's so simple. But if you're interested in other things, it's all here. They have everything. Okay. So I just thought you'd find that interesting. Anyway, so you can see here, the code is written to be very English-like. but there are certain quirky rules that we have to use in order to use it correctly. There's rules that are, we cannot break them, period. And there's other rules that are optional. So we're going to start by introducing the VBA editor itself and learn how to type in a program. We're going to learn how the language is structured, and we're going to see a lot of examples. So the VBE, as it's called, the Visual Basic Editor, is used to actually write your code and then run it and debug it if necessary. So you must first, like I showed you, activate the developer tab, which is in there, but it isn't visible to you unless you update the ribbon. I don't know why they do that. That's just the way it's done. Right. They also have a nice optimization package built into there called Solver. And they also have a nice statistical package called Data Analysis Toolpack. They both have to be installed as well, although not in exactly the same way. In fact, while we're on the subject, if you're interested, let me show you how that would work. Oh, actually, I think that's already installed in mine, but still, yeah, right here on the data tab. If yours are installed, they would be here at the end under Analyze. If not, with the PC, you would hit Options, Add-ins, Go, and then it'll have a list. Mine are checked on the Analysis Toolpack and the Solver add-in. Analysis Toolpack is for statistics. Solver is for optimization. We may use these later on, but primarily we'll be using the VBA. On the Mac, I think they may be there's a tools menu, if I'm not mistaken, that has those listed on them somewhere. So you can download them in a slightly different way. And if you've been successful, you'll see that here's data. At the end, it says data analysis and solver. Now, interestingly enough, if you know what you're doing, you actually can access these functions in VBA, but it's fairly complicated. Notice you can borrow solver while you're in VBA and use it if you need to optimize something, but we're not going to do that here. What's interesting about VBA is that it uses Excel for the most part, but it has its own functionality as well. And so it's going to take a little getting used to because sometimes we're using VBA itself and sometimes we're actually using Excel. But anyway, the editor looks like this. Now, this picture was taken from an older version of Excel, but it's supposed to have at least these functions on there. Let's take a look. Actually, I'll tell you what, oh no, it should be okay over here. So on the developer tab, you've got editor and macros. Here it's called Visual Basic. Like I said, this is a slightly older version of Excel. Record and relative reference. Now, I do want to mention here that there are two basic types of programs we can write in VBA. And one of them is called a macro, which is basically a string of commands that the computer will execute automatically. And it can be created by literally having it record your keystrokes. So that's the kind of thing that you might do. Let's say that every morning when you get to your desk at work, there's certain routine tasks that you always have to do. Like you may have to open up a certain file, you may have to look up certain information, copy it into a spreadsheet, look up the time, things that are always the same no matter what. Those are the kinds of routine repeated commands that can be recorded in a macro. So instead of doing all those steps, you can just punch a button and it's already done for you. We're not going to do that. We're going to write actual programs, okay? But we have the capability of creating macros that do actually execute code to price derivatives, for example. And so we'll see as we go along when to use each approach. But anyway, we have all these windows. Now, a lot of this is designed to help us debug our code when something goes wrong. Now, this is unfortunately one of the weakest parts of VBA. When things go wrong, it doesn't really do a terribly good job of explaining to you what the problem is. It'll show you where the issue is, but we have to interpret what it's telling us. So, but there are all kinds of windows here available that we can use to help us keep track of what the program is actually doing. Okay, now they're not all visible all the time. These are the code windows. And then some of these others are not open at the moment. All right, well, let's go through these now. A code window contains a VBA procedure, which is either a subroutine or a function. A subroutine is a macro, by the way. As an example, we have, this is example 3, which lets us calculate how much we spent on gas. So that would be, it's here somewhere. There it is. So now, if you notice, there's blue and there's black here. These are known as keywords. These are words in VBA that you must use for that purpose only. You do not have any flexibility with the keywords. They have a certain meaning, and that's the end of it. If you misuse them, you'll only end up with errors. In other words, you don't want to call one of your variables sub because that's already reserved. So it'll tell you this with the blue. So you have here gas expenditures. This is actually the title of the subroutine by which you will call it if you want to run it. And then you'll notice that we have, two variables, two constants that we've defined. Price of gas, which is defined as $2.25, and number of gallons, which is defined as 20. Now, in this very simple program, we are not actually sending any information to it. That's already built into the program. So you don't really have any flexibility here. And what it does then is it calculates the total spent very simply as the price of gas times the number of gallons. But how does it send that information back to the program? Or the Excel spreadsheet, rather. That's what these are for, debug.print. Okay, so if we execute this, let's see, let's go back here. Oh, here we are. Okay. So now if you remember, we called this thing gas expenditures. And by calling it a subroutine, that means that it is a macro. If it's not a macro, it's a function. Okay, we'll get to that in a minute. But a subroutine is a macro, and the macro dialog box shows you all the macros you have to choose from. And so all you have to do is hit gas expenditures. Now, you notice nothing appears to have happened. That's because the output was sent to this thing called debug print. And that is a special window that's designed to let us see the intermediate results of some program that we're working on. So that would be found, the so-called intermediate window, which is found, let's see, here it is. If you can't find it, just click that thing on. And it's showing you the now. So the point of doing this is that you can look at and say, you know what, that is correct. I can carry on and continue developing this program, or I can tell it to print this information onto the spreadsheet. But this is designed for internal purposes. I want to know before I do anything else that these numbers are working correctly. If not, now's the time to fix them. So that's the intermediate window. And this is potentially very helpful for debugging purposes. If your program doesn't seem to be working, you can create this immediate window and ask it to print the variables and make sure that they're doing what you think they're doing. Okay. Now the locals window is showing you the process as the variables change throughout the program, what exactly is happening. So let's go back to the here we go. Okay, well, because we didn't include any variables, there's nothing in here. But if we did, it would keep track of how every time you change its value, it would keep track of it here. But because we use constants, it's got nothing to keep track of. It's saying, oh, okay, you did a calculation, fine. Okay, and by the way, you don't have to use these windows. These are there just in case you need them. The watch window is again something that helps you see, make sure everything is going the way it's supposed to go. And here's what it looks like. Same thing. There were no variables, so it doesn't have any information for us. Properties windows. Now this is where it gets complicated. This is where you can change different information. When we look at some more complicated problems, we'll see that it fills it up with a lot of useful results. Right now, for such a simple case, it's also blank. But we'll definitely need these. Now, the object browser, this is the object browser, by the way. Oh, I'm sorry, here it is. I was looking at the wrong part. This is going to tell us a lot of useful information. These are actually all the functions that we have access to. And the project, this is the project browser, sorry, what we're looking at here. So it doesn't even offer us a link to it because we're already in the project browser. So this is where everything comes together. Or Project Explorer, sorry. Yeah, that's what we're seeing here. Okay, so what we're going to do now is go through these examples, and there's quite a few of these, which is good because they'll help illustrate a lot of the functions, or what I should say is the structure of the VBA language, because that's really what we need to focus on right now. There's a handful of things we have to know before we get started, and so we'll do that next. So I think, wow, it's already, I guess we're kind of done with today's session. So the next time we meet, what I will do is I'll run through these, and like, for example, you can see it's getting a little bit more complicated. There's quite a few keywords in here, and a lot of more interesting concepts are being introduced. And so when we're done, you'll have the ability to write some simple programs of your own, and then we can get started on the assignments. Okay. All right. So I guess we'll knock it off right here. And what you should do is make sure your VBA developer module is installed, and at least get that done. And then next time we'll run through, and if you want, you can go through these codes and see if you think you know what they're doing, or run them and see what happens. But I do want to mention though that running the functions is different than running the macros. The macros, you can just go right up here to the macro button. The functions, you have to know how to implement them. So we'll save all the discussion for next time. Okay, and I think you'll find it quite interesting, especially if you have any programming background. So all right, I guess I'll see you all next time.